Hello and welcome to BP1168 Logging 201, also known as How to Effectively Use Rancher's New Logging Integration. My name is Eamon Bauman and I'm from SUSE, formerly of Rancher Labs, in the field engineering area. Our agenda for today will cover several different topics as they relate to Rancher's new logging integration. We'll begin with an overview of Rancher's historic logging integration and how it compares to today. We'll cover multiple log destinations, how to use Fluentd Filters, where to adjust Fluentd and Fluentbit settings, and we'll finish with a coverage of general best practices. To start off, a brief overview of Rancher logging. The original Rancher logging integration, which existed prior to version 2.5, was heavily dependent on Fluentd. Fluentd ran both as a daemon set and as a deployment inside of the Kubernetes cluster. The daemon set that was running was responsible for going onto each node and collecting logs from all of the containers running on those nodes. The Fluentd deployment sat centrally in the cluster and acted as an aggregation endpoint for all of the distributed instances of Fluentd. There were several issues with this approach. First and foremost, this approach was only project and cluster based, which means if I wanted to configure logging at a namespace level or do targeting at the pod or workload level, I was out of luck. I could only configure this logging integration at the cluster level, meaning to select workload logs from across the entire cluster, or at the project level to select workload logs from an entire project. I didn't have any more specific filtering than that. We were also limited to using only certain log outputs: Elasticsearch, Fluentd, Kafka, syslog, and one other that escapes memory now, but there were no other options outside of that. We also had limited customizability of the logging integration, meaning I did not have exposure of the full litany of Fluentd and Fluentbit settings that are available in the new logging integration. I also didn't have many options for filtering, customizing, or transforming the logs as they were being collected from my workloads. Fast forward to version 2.5, and we've now introduced the Bonsai Cloud Logging Operator. The Bonsai Cloud Logging Operator instruments and operates Fluentd and Fluentbit for log collection, transformation, and delivery. This differs in a few ways from the historical Fluentd integration. First, we've replaced the daemon set that was formerly Fluentd with Fluentbit running on each node. We've added additional destinations that allow log streams to end up at different aggregation points outside of the list I provided earlier. Fluentd filters can now be added for parsing, transformation, and other options that allow you to adjust the logs as they go through your stream. Logs can flow to many destinations versus just one. Something I didn't mention about the legacy logging integration was that you could only select from one of those destination endpoints at a time. It was Elasticsearch or Fluentd or Kafka or syslog. I couldn't choose multiple outputs at once. Finally, the Bonsai Cloud Logging Operator gives us fine-grained log collection rules for Kubernetes. This means I can record logs down to the specific container, instead of having to collect them from an entire project or an entire cluster's worth of containers. Bonsai Cloud Logging has 4 different main resources that are used for configuring log streams. On the left, we have the concept of an output and its cluster-scoped analog, a cluster output. An output is responsible for determining a destination for logs. This could be something like, again, Elasticsearch, Kafka, Amazon S3, any different options. We can configure multiple outputs for our logs, and the cluster output resource is available across the entire cluster, or a plain output resource can be available as a namespaced object. An output is a destination for logs. It's how we configure where we want those logs to end up. On the right-hand side, we have flows and cluster flows. These define matching rules for log collection, filters for transformation, and they allow us to set up one or more destinations for our logs. When we create matching rules, we can match based on pod labels, we can match per node, or, as I said before, we can get container specific and identify particular containers whose logs we wish to obtain. When we define Fluentd filters, we can transform log entries by doing JSON parsing, GeoIP, adding or removing values from the log file or log entry. And then finally on the flow, we can set up one or more destinations for logs. In contrast to the legacy logging, we can set up multiple destinations here, so our log flows can end up to Elasticsearch and Fluentd and syslog all at the same time. This presentation, however, is a 201 level presentation. More details on the logging basics can be found inside the Rancher docs. However, with the remainder of this presentation, we're going to focus on best practices. The first best practice I'd like to get into is multiple log destinations. When we talk about multiple log destinations, we're going to focus both on cluster outputs and on namespace output objects. When it comes to cluster outputs, we recommend that you designate one or more cluster-level log destinations. There are a couple of use cases we can get into for this. The first is a log everything endpoint. This could be good for SIEM applications, for central visibility, for audit logging, or for compliance. We can also use this for test or dev flows without needing a specific endpoint. In the case that your developers are writing a new application and need to test the log output for this, instead of having to define a single destination for those new application logs, you could use a catch-all log output and have the developers review that sort of stream of everything that's coming through. By designating cluster outputs, you remove the work that would have to be done on a per application or per project basis by having a central destination for logs that you, the administrators, can pick apart in your destination log tool. When we talk about multiple namespaced outputs, we'll want to separate our outputs on a per application or per interest area delineation. When it comes to per application, I'm talking about having an output for application A, an output for application B, an output for application C. When it comes to talking about per interest area, we may be creating a log output as a destination for security logs, another log output for audit logs or for trace logs. Generally, this goes well with applications who log that type of traffic to different log files. So if your application is able to separate out trace logs and security logs and audit logs, you can set up multiple outputs to receive those types of traffic at different endpoints. Using Fluentd filters. With the Bonsai Cloud Logging Operator, we now have the ability to define Fluentd filters on flow resources. This allows us to transform our log entries as they pass through the log stream, make adjustments to individual log entries before they end up at an aggregation endpoint. Multiple filters can be applied per flow, so you can set up a chain of filters that will apply to each log entry that comes through. For example, we could add JSON parsing for structured logging as the first filter in our flow. When a new log entry comes through, that message field, for example, would be parsed for JSON content, and the resulting key value resources could be inserted as entries into the log itself. We could then grep for pulling unstructured logs also into a key value format. Perhaps we're obtaining system logs like a syslog output. We could use a structured syslog parser or write our own to pull out information critical to our application and parse them into key value entries. Another really helpful flow to look at is the Concat Flow or Concat Flow. Filter. This allows us to turn multi-line events into a single log entry. A really important use case for this is stack trace events. If I have an error in my application that results in a stack trace, without applying the Concat filter, I may only get the first line entry of that stack trace. By using the Concat filter, I can rest assured that all of the lines of that stack trace will be concatenated into my flow and that my log entry will be complete, including that full stack trace. An example filter is shown on the screen here. This is a basic JSON filter for parsing the message field into standard key value separators. What would happen here is when a log entry comes through our flow, I'm visualizing a pipe of log entries. When a log entry comes through our flow here, we would take a look at the message field on that log entry. What we're saying with this filter is that message field is assumed to be full of JSON content. We will parse that content and then pick out the key value entries in that JSON blob and turn those actually into log entries. So now instead of having message and JSON blob, we will have key value for the contents of that message field. Again, this is added as part of a Flow resource. And one thing I also want to bring to your attention is on line 25, note that this is an element of a list. We can, and in some cases should, have multiple filters in the same flow to ensure a proper and complete transformation of our log entries. When it comes to adjusting Fluentd and Fluentd settings, we have options in the Bonsai Cloud Logging operator. In the legacy logging integration in Rancher, we did not have exposure of the long list of options we do today. To adjust Fluentd and Fluentd settings, we can take a look at the logging resource. I lied a little bit earlier when I said there were 4 resources only for configuring logging: flow, cluster flow, output, cluster output. We also have what's called a logging object. It is a custom resource installed as part of the Bonsai Cloud Logging operator. A logging resource controls all of the settings for Fluentd and Fluentd. A logging instance, therefore, corresponds to an instance of the Fluentd stateful set for central log collection and the Fluentd daemon set for distributed collection from all of the nodes in the cluster. When you want to adjust specific Fluentd settings or Fluentd settings, you will need to configure those on this logging resource. When you install the Bonsai Cloud Logging operator into an RKE cluster, you will get 2 of these logging resources deployed by default. As you can see on the screen, the Rancher Logging and Rancher Logging RKE loggings come out of the box when you install this integration. There's a gigantic list of supported options available at the URL that you see on the screen. There's too many to go through in a comprehensive way today, but I encourage you to check out the various options that are available. We have some sample use cases for why you'd want to configure Fluentd or Fluentd configuration options. The first, for Fluentd, is you may want to configure buffer storage. Intense logging in a cluster can overflow pod local storage for buffering. This means that when I have many different log files being flowed to that central Fluentd instance, and I am not sending those to my aggregation endpoint quickly enough, we can overflow the buffer space, which by default resides in pod local storage. In this case, we could designate a persistent volume or a host path for buffer storage, which would make more room available for our buffer to expand before sending those log entries out to our aggregation endpoint. For Fluentd, we may want to customize flushing of logs. In our example of intense logging, we may have many nodes collecting hundreds or even thousands of pods worth of logs. In these cases, those could be high traffic applications generating tons of log entries per second. We may want to increase the buffer flushes in this case so that our Fluentd instances don't also suffer from a buffer overrun. Conversely, if we're seeing slowdowns by Fluentd flushing those logs out to an aggregation endpoint, we may want to increase the buffer or slow down the flushing of these Fluentd endpoints so that we're not overwhelming our central Fluentd instance. Another Fluentd configuration option we may want to change is custom log files. Custom log files will allow us to define log files on the nodes themselves, whose entries we can then review and pull into our log flow. The input tail directive allows us to target files for log scraping. This is similar in a Linux world to using the tail-f command, whereby we will tail the file and grab new entries as they are appended to that log file. Finally, we'll end with some general logging best practices. General best practices are as follows. You should have at least one cluster flow for total central logging. That means in every one of your Kubernetes clusters, define at least one cluster flow and one corresponding cluster output to grab all of the logs in the cluster. This mandates a catch-all for those logs, which is great for seam feeds, for using security tools, or just general auditing and archival purposes. Another thing to mandate is that all workloads must come with a flow object in the deployment or the chart. This takes the workload off of the administrator and operator by having the developers target their logs to particular destinations, to allow them to select particular logs and apply transformations as they need to for those log entries. Don't make operations responsible for wiring up the logging. Make the developers tell you what's important, what the defined output is from an application, and where they want that to go. Try to enforce structured logging output of applications if possible. JSON here is going to make your life much easier. As you saw in our filter example, we had a simple one-line filter, actually it was 4 lines, for doing JSON filtering of log entries. If your application is able to spit out those JSON log entries, your life will be easier because you won't have to come up with these unstructured logging parsers. If you spit out unstructured logs, we have to pick through and find the various pieces of information we're interested in, parse those into log entry fields, and it adds overhead both on our development effort and ultimately on the workload of Fluentd and Fluentd. If we can output structured logs, it's much easier for a computing operation such as our logging application here to filter those logs and make them into a structured arrangement for us. Finally, where possible, use Rancher's fleet and continuous delivery to roll out configs. Fleet is outside of the scope of this presentation, but in a nutshell, it is GitOps at scale. The ability to take resources that exist in one or more Git repositories and deploy them to one or more downstream clusters. If possible, source your flow and output objects in a Git repository to deploy them to all your clusters. This ties in well with the first example in our best practices of having a cluster flow and output available in every Kubernetes cluster. When you source these resources in a central Git repository, you can control their versioning, their rollout, and quickly make changes as needed to your entire fleet of Kubernetes clusters without having to go cluster by cluster. Thank you very much for attending BP 1168 Logging 201. If you have any questions, comments, concerns, or feedback, please feel free to reach out to me. My email address is eamon.bauman@suse.com. Thank you very much.